The next topic is potentiometer. First of all, why we need the potentiometer? That is the basic question, and we are going to answer that question. As we know that epsilon is the EMF of the battery and small r is the internal resistance of the battery, and V is the potential difference between these 2 points, and the current flowing through the battery is I. So we can say that V is going to be epsilon minus IR. Now we want that EMF produced by the cell, so we can say that V will be equal to epsilon. But if we are considering this equation, there are only two conditions. One is I should be equal to 0 or R should be equal to 0, but small r, that is internal resistance of the battery, and it cannot be 0, and that's why we have to switch over to the condition that I is equals to 0, and that is called open circuit condition. Now what is the principle of the potentiometer, or what is potentiometer actually? We are, as seen in the figure, we are going to consider one cell with EMF epsilon and internal resistance of small r. The external resistance has been connected with it, and a wire of length A to B has been connected with it. So we can say that AB is nothing but length of a wire, and that is going to be L. Rho is called the resistivity of the wire, and point C is the null point. Null point is the point where we are going to have the current 0 within a circuit, and for that we are considering the length of AC, that is equals to small l. Now from the conditions we know that V is equals to V, that is epsilon minus IR, that is going to be IR plus IL rho, because L rho is nothing but the resistance of the wire AB, and small l into rho is nothing but the resistance of the wire AC. Now if we are simplifying this condition, we are going to have the equation that epsilon is equals to I capital R plus L rho plus small r, and that's why we can say that I is equals to epsilon upon capital R plus L rho plus small r.